So what we're going to do in this video is we're going to test, first of all, test the point is on a line. So to test if a coordinate is on a particular line, we can substitute the x coordinate into the equation of the line and calculate the y value, then determine if it's correct. If you get a different y value, the coordinate is not on the line. For more complex questions, you can substitute the entire coordinate in and see if both sides balance. If they do, the point is on the line, and if they don't, the coordinate is not on the line. So we've got a few examples here, 5 examples of how we're going to do this. And it just says quite simply, does the point, and first one, does the point 1, 2 lie on the line y is equal to x plus 1. So all we're going to do is put the x value here is 1, so we're going to put that in and see if it works. So y is equal to, instead of x, we're going to write 1. Y is equal to 1 plus 1, and 1 plus 1 gives you 2. And sure, 2 is what you have for your y value, so that means that point 1, 2 lies on your line. So just say yes. Dead easy. Example B. Example B says we've got 0, 4. Does 0, 4 lie on the line? Y is equal to minus 17x plus 5. So again, we're going to put your y equation is minus 17 times your x value is 0, plus 5. Let's just do that out. Minus 17 times 0, anything times 0 is 0, plus 5 then, so your y equals 5. So we have found when x equals 0, y equals 5, so that means this one is not correct. So 0, 4 is not correct. So your answer for this one is just no. Okay, part C says, does minus 1, minus 3 lie on your line? Y is equal to x minus 4. So your y is going to be equal to, your x value is minus 1, and then minus 4. So if you do that, it's going to be minus 1 minus 4, but minus 1 minus 4 is minus 5. So it is not the same as we had over here. So again, this one does not lie on your line. Okay, part D says, does 2, 7 lie on your line? So again, your y value is equal to a half. Put in your x value, which is 2, plus 6. So let's see what happens. A half times 2, half of 2 is 1. And then plus 6 gives you 7. So that works because you've put in your x value and you've got x value of 2. And you got your y value of 7. So happy days, that one works. So yes, it does. Okay, our last example of this type is a wee bit different. You've got the point 1, 1, and does the point 1, 1 lie on the line 4x plus 3y is equal to 10. So in this case, 4x plus 3y is equal to 10 means that your x value is 1 and your y value is, you've got your x value is 1, your y value is 1 as well. And you want to put them both in at the same time. So we'll just say here, we sub in both. So your x, which is 1, goes in, so it's 4 times 1. Your y, which is 1, goes in. So you have 4 times 1 plus 3 times 1, which is going to just be 4 plus 3, which is equal to 7. But we were hoping our result would be 10. So this one clearly does not lie on your line. Okay, line segments. A straight line graph continues on forever, but a small section of a line is called a line segment. We are able to find the length and the midpoint, which is the middle of any line segment. Always draw a sketch if not provided, and to find the midpoint, average out the coordinates, and to find the length, create a right angle triangle and use Pythagoras' theorem, which we have just seen really very recently. Okay, so as well, can we add in here down the side? We're going to look at this one here. So a slightly different way of saying it. So if here, can you just put in a wee bit extra notes? Just say if 2 points are, and I'm saying x subscript 1, y subscript 1, and x subscript 2, y subscript 2, just say then the length is equal to, and you'll see more in a wee minute where this comes from, but it's from Pythagoras' theorem. You do your x1 minus your x2 and you square it. And then you do your y1 minus your y2 and you square it. And then it is the square root of everything. Also, the midpoint is equal to, and this is a coordinate, so it's x1 plus x2, and then all divided by 2, and y1 plus y2, and all divided by 2. So can you copy that one down, please? We're going to be using that for our part B. We'll be using that. That's going to be how we're going to do it. But for part A, we're going to do it slightly differently, as you will see. Okay, example A says find the length and midpoint of the line segment. So we've got 1, 1 and 7, 9. That's we're going to find the length of this thing. So this is just a sketch, folks, but what we're going to do is complete a right angle triangle. So I'm just going to, on this one, I'm going to do my right angle. And this length here from here to here then would be from 1 up to 7. So it's going to be 6 long. And this length vertically would be from 1 up to 9, which is going to be 8. So we can use Pythagoras to find the length of this line segment. So your length is your hypotenuse, remember? So the hypotenuse is going to be 6 squared plus the 8 squared and the square root. And that's going to be 36 plus 64 and the square root of that, which is the square root of 100, which is lovely. It's just going to be 10 units. Likewise, to find the midpoint is this bit here. So it's halfway along. So it's halfway between 1 and 7. So we have to average those things. So the midpoint in this case is going to be 1 plus 7. So what I've done here is I've taken the two x bits, the 7 and the 1 down here. I've added them, and then I'm going to divide by 2. And I'm going to do the same for the y bits. So the y bits are 1 and 9. So I'm going to do 1 plus 9, and then I'm going to divide by 2. So a couple of steps to do this. First step, just to add the 1 and the 9, you'll get 8. That's over 2. Sorry, add the 1 and the 7, you'll get 8 over 2. Add the 1 and the 9, you'll get 10. That's over 2. And then your last thing is just put that in. That's going to be 4, 5. So just do 8 divided by 2 to give you 4, 10 divided by 2 to give you 5, and that's it. And if you can imagine here, if you marked on the point 4, 5, it would be the midpoint of those as well. So get that one copied down, please. That's your example A. We're going to do example B slightly differently. Our example B says you've got minus 5, 3 and 2, 6. So we're going to use this way of doing it over here. So 2 points are x1, y1. So our x1 is minus 5 and our y1 is 3. And then our x2 is 2 and our y2 is 6. So we're going to use this formula here. This saves you having to draw out a sketch, and there are times where it's not going to be practical to draw out the sketch. So if we have a formula for it, it is much better. So we'll write down a formula we're going to use again. It is going to be the square root of x1 minus x2, that gets squared, plus y1 minus y2, that gets squared, and then we're going to go with that. So your x1 was minus 5, your x2 was 2, minus 2, so your x1 was minus 5 and your x2 was 2, so it's minus 5 minus 2, that gets squared, plus, and then your y1 was 3 and your y2 was 6. So tidy that up. Minus 5 minus 2 is minus 7 squared. Sorry, making a mess here. That's minus 7 squared. And then plus your your 3 minus 6 is minus 3 squared. And you've got to do the square root of all of that, which works out to be the square root of 49 plus 9, which is equal to the square root of 58. And we will say that is equal to 7.6 to 1 dp. Very last bit of notes, just say your midpoint is equal to, and again we'll write down our formula, hopefully I have enough space to squeeze this in. It's x1 plus x2 divided by 2, and y1 plus y2 divided by 2. This formula for some reason trips people up. It's nothing to worry about at all, folks. All we're doing here is you're taking the two x values, adding them, taking the two y values, adding them, and then both those things are being divided by 2. So our two x values were minus 5 and 2, and then you're dividing that by 2. Your two y values are 3 and 6, and you're dividing that by 2. And then if you do that, it's going to be minus 5 plus 2 is minus 3, and that gets divided by 2. And 3 plus 6 is 9, and that gets divided by 2. And when you do that, what you get is minus 1.5, 4.5. And that is it. Okay, so we now know how to test if a point is on a line, and we also know how to find the length and the midpoint when you're given 2 points on a line segment, or the length between 2 points and midpoint of 2 points if you're just given those 2 points.